Greetings to all of you. The session is regarding intermediate chemistry, will be helpful for the preparation towards your international entrance or any competitive exam you're aspiring for. In the national level JEE Advanced, JEE Mains examination for IIT and NIT examination, that will be a technical domain, will be fetching for engineering stream, and NEET chemistry for medical entrance across the India. So that is the kind of pharmacy related field, medical related field. In addition, Telangana and Andhra Pradesh entrance examination called MSET, right? Which will be fetching for engineering examination. Engineering is a multi-dimensional stream where to so many technical exposure we will get about that one, and that is a career oriented kind of educational course. In addition to that one, if the people who are aspiring for clearing the government career, government competitive examination, at that platform also, the content what we are discussing will be very much helpful. In what way it will be helpful? So the people who are preparing towards the government examinations, they must have the idea about all the kind of dimensions, all the concepts, international floor, what is going on, the national level, what is going on, what is your past history, what is the geography, what things are going. In all possible dimensions, we have to think. At the same condition, we have to know about general science related. Okay, so what is happening and what kind of things are going on in the field of science and technology as well, right? The content what we are discussing will be very much fetching for that general studies, general science concepts. Let's enter into our today's session. Explain the geometrical isomerism of the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. Here is the compound provided. We need to assign the geometrical isomerism. Basically, geometrical isomerism can be categorized into two ways: cis-trans isomerism, EZ isomerism. What change or what difference we can notice between cis-trans and EZ nomenclature? Cis-trans is assigned for the double bonded compounds which are having only two different functional groups around the double bond. But EZ will be assigned whenever carbon-carbon double bond is surrounded with the four different functional groups. At that condition, EZ nomenclature is applicable. This is the way geometrical isomerism gives the orientation of the functional groups around the carbon-carbon double bond, where restricted rotation we can notice. Here is the logical compound provided, where you can notice two double bonds over there. One of the double bond is there on the carbon number 1 and the second double bond is there on the carbon number 3. But where we have to assign EZ nomenclature or else cis-trans isomerism. Being it is the kind of two double bonded compound, is it required to apply EZ nomenclature for both the carbon atoms, or else only once at one point only we have to assign? That thing we have to clarify. In order to get the clear explanation and the entire name of the compound as per the IUPAC protocol, let me show the compound in a detailed manner. The same compound can be written like this. Here, double bond is located as carbon is always satisfied with the 4 valency called tetravalency. Always carbon can be accompanied by 4 bonds. In order to make the 4 bonds, already double bond is there one side and one chloro bond is there. 3 bonds completed, no? So that 4th valency got satisfied by inserting a hydrogen over there. This is the way you can notice around this carbon atom, hydrogen, chloro, and any other double bond is located. And second carbon atom is having one side ethyl, one side carbon, carbon double bond over there. This is the way all 4 functional groups around the double bonded carbon are different. So at this junction, you can go with the EZ nomenclature. Fine. Let me consider in either double bonded carbon atoms. This double bonded carbon atoms, one side we are having this ethyl, carbon atom. In either side, obviously hydrogen will be there. But second, that means a terminal carbon, if you consider, two sides hydrogens only, this side hydrogen, this side hydrogen. There is no possibility to assign geometrical nomenclature whenever double bonded carbon is accompanied by two hydrogens, two similar atoms. At that condition, geometrical isomerism not applicable. So that there is no ambiguity for this double bonded carbon. Only this double bonded carbon will be assigned for the EZ nomenclature. I think it is very clear regarding the geometrical isomerism. After getting this point, we have to assign priority in accordance with the Kahn-Ingold-Prelog rules. To assign the Kahn-Ingold first rule, higher atomic number will resided with higher priority. Among chloro and hydrogen, obviously chloro is of higher atomic number. Let me put 1 as a priority. Hydrogen of least atomic number, second priority. But if you move on to second carbon atom of the double bond, there is an ambiguity for two carbon atoms. If you go for numbering, priority for carbon and carbon as well, how can we give numbering? Because both are carbons, right? Then at that condition, we have to go for the rule number 2. What it says, whenever any carbon is accompanied by the double bond, you have to treat, there are two bonds, two separate bonds are located. That indicates this carbon further bonded with two carbons individually. That is the way we have to think about it. But this side, the carbon is bonded to one carbon only. This carbon is bonded to two carbons. This carbon is bonded to one carbon. Obviously, double bonded carbon will be given higher priority over single bonded carbon atom. That's the reason why here assigning 1 for double bond, 2 for single bond. After getting this priority, if you see overall, two priorities are on the same side. Two higher priorities are laying on the same side. So that let me put Z. Z for Jusamin, which indicates two higher priority laying on the same side. This is the way Z is assigned. After getting Z, entire IUPAC name to be assigned. For that purpose, the first thumb rule for the IUPAC nomenclature is longest chain will be the parent chain. For that, first carbon is having chloro, second carbon is having ethyl, third carbon is having double bond, and first carbon also having double bond. So, according to the alphabetical order, chloro comes first over ethyl, C over E, right? That's why. So, after putting this Z, Z for Jusamin, same side, two priority, it's finished. Then chloro is laying on first carbon. So, that one chloro, let me put. And on second carbon, ethyl is there. So, that two ethyl. On first and third carbon atom, you can notice the two double bonds. And being it is the 4 carbon, parent chain will be buta. So that 1, 3 butadiene. Entire name will be Z, 1 chloro, 2 ethyl, 1, 3 butadiene. This is the way we have to give the nomenclature. So if you understand what are the rules in geometrical isomerism, what are the rules in IUPAC nomenclature, then only we have to resolve the problem whatever given. So that it's a simple way to give the name. Let me repeat. It is given with the Z as per the EZ nomenclature, and chloro is present on 1, so that 1 chloro, 2 ethyl, 1, 3 butadiene, right? For question number 1, this is the way we can answer. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. The question which is given from inorganic section, where stoichiometric relation we have to go for. Stoichiometry stands for what is the balanced equation? How can we balance the equation in terms of atoms and everything, right? Aqueous iron 3 sulfate and aqueous sodium hydroxide are reacted to give precipitate of iron 3 hydroxide and a solution of sodium sulfate. So the simple way they're asking the question, the thing is the entire equation, reactants are themselves, they are giving reactants and products as well, right? So whenever reactants and products are given, only the thing we need to solve is the balanced symbol equation. This is purely logical based, because if you know how to balance the equation, then only it is possible to get the balanced symbol based equation, right? So here, whatever numbers are mentioned in a Roman letters in this bracket denotes what? Oxidation state around the central metal. Iron 3 sulfate is nothing but ferric sulfate. And here sodium hydroxide will be treated. So that precipitate of iron 3 hydroxide, ferric hydroxide, and one more will be sodium sulfate will be formed. Right. So in order to get this, in all the options, if you observe, whatever they are saying, reactants and products, same are given. That means ferric sulfate reacted with sodium hydroxide, ferric hydroxide and sodium sulfate is given. So what they are saying, exactly same reactant, same products are there. Only the difference is coefficient. That means balancing the equation. Okay. In order to solve this type of problem, we have to go for law of conservation. Law of conservation denotes what? Number of atoms laying on the reactant side exactly is equal to number of atoms which are present in the product side. How many atoms are they reacting? Those many atoms should be produced, but in the different form. That is only required, but the conservation is most important over there. Okay, in order to get that, this is the balanced equation and the coefficients are highlighted with the blue color, right? So here, ferric sulfate, if you are going to treat, if you count the number of irons, how many are there? 2 irons. 2 irons can be compensated with 2 irons in the product side, so that you can cancel 2 iron with the 2 iron. Then count the sulfate atom, sulfur atoms. Sulfur atoms is taken with the thrice. That means the sulfurs are 3 in the reactant. In the product side, in the SO4 only we have 1 sulfur, but in front of Na2SO4 you have 3 coefficient. This 3 is common for all atoms, so that 3 number of sulfurs are there, so that you can cancel sulfur as well. Oxygens are 4, O4 they mentioned, and behind the bracket again you have 3. This indicates what? You have to multiply 4 with 3. Total oxygen atoms are 12 over there. But this is not completed. All oxygens are not completed. And here also we have some more oxygens. Oxygens with a 6 coefficient. So that 6 oxygens are there in sodium hydroxide. 12 for sulfate and 6 for NaOH. 12 plus 6 total 18 for reactant side. Okay, reactant side oxygen count is 18. Let me move on to product side. In product side, oxygen got thrice. O taken thrice is given, and moreover this 3 is coefficient 2, so that multiply 2 multiplied with 3, 6 times oxygens are there. So 6 times oxygen in this ferric hydroxide. Move on to this one, SO4. SO4 oxygens are 4, but this SO4 is having 3 coefficient. Multiply 3 multiplied with 4, 12. 12 oxygens are there in the Na2SO4. Okay, 6 is for ferric hydroxide, 12 is for sodium sulfate. So that 6 plus 12, 18. 18 count reactant side, 18 count product side got compensated. Oxygen balanced. Move on to sodium. Sodium coefficient 6. So that 6 sodium atoms are there, reactant side. Then Na2. Na2 and coefficient is 3. Multiply. 3 multiplied with 2, 6 coefficient for sodium. Sodium 6 reactant side, sodium 6 product side, compensated. Move on to hydrogen. Only the left thing is hydrogen. 6 hydrogens are there. Here, hydrogen taken thrice you mentioned, and this is for coefficient 2. Multiply. 2 multiplied with 3, 6. So 6 hydrogens reactant side, 6 hydrogens product side. Entirely balanced. This is the perfect balance. This indicates what? 1 mole of ferric sulfate reacted with 6 moles of sodium hydroxide gives 2 moles of ferric hydroxide and 3 moles of sodium sulfate. This will be the completely balanced equation. Entire atoms reactant to product side are equal, right? So for question number 2, option number C will be the correct answer. Move on to question number 3. Question number 3 collected from JEE Advanced 2019 question paper, paper 1 question it will be. It is the kind of analytical and moreover titrimetric analysis, volumetric analysis question it will be. For the following reaction, equilibrium constant Kc at 298 Kelvin is 1.6 into 10 to the power 17. Fe plus 2 aqueous plus SO4 S minus 2 aqueous gives rise to Fe is solid. Okay. Fe plus 2 ferrous ion aquated, sulfide ion aquated gives a ferrous sulfide solid compound will be generated when equal volumes of 0.06 molar Fe plus 2, 0.2 molar S minus 2 solutions are mixed. Then equilibrium concentration of ferrous is found to be Y into 10 to the power negative 17 molar. The value of Y is Y to be anticipated. Okay. Same question given in Hindi as well. 298 Kelvin पर निम्न अभिक्रिया का साम्यावस्था स्थिरांक Kc equilibrium constant 1.6 into 10 to the power 17 है. Fe plus 2 aqueous plus S minus 2 aqueous gives rise to ferrous sulfide solid. जब 0.06 मोलर फेरस एक्वस और 0.2 मोलर S minus 2 एक्वस के समान आयतनों का मिश्रण किया गया तब Fe plus 2 एक्वस की साम्य सांद्रता called equilibrium concentration Y into 10 to the power negative 17 molar पाई गई. Y का मान है value of Y to be identified. Its answer is required to be calculated as 8.92, right? How we have to get this answer? So let's go with the sequential solvation for the question. Fe plus 2 aqueous, S minus 2 aqueous gives rise to ferrous sulfide, whose equilibrium constant is given as 1.6 into 10 to the power 17, right? So ferrous ion taken as 0.06 molar concentration. Sulfide is 0.2 molar, right? So if 0.06 molar is mixed with 0.2 molar, you can mix up, you can make half. So 0.6 can be halved to 0.03 so that it will be halved. Okay, so 0.2 molar will be halved to 0.1 molar. This is the way we can simplify the equation, right? So if this is the case, what will be the Kc? Kc is equal to equilibrium constant is equal to 1 by ferrous ion concentration into what? Sulfide ion concentration, right? So this will be called product of ionic concentrations. Okay. Kc value is known to you, that is 1.6 into 10 to the power 17. So that you can put over 1.6 into 10 to the power 17. 1 by ferrous need to be calculated, whose concentration is required to be identified. Sulfide concentration is 0.07. Now, if you are taking this Fe plus 2 towards the left hand side, then whatever value is there, that will become a denominator, right? So when you are taking this as a denominator, what happens? 1.6 is coming to denominator, and whatever 10 to the power 17 is there, if it is taken up, that will become negative, because denominator actually, but if you are moving to numerator, whose sign convention will be changed, negative 17 we have to put on, and S minus 2 concentration remains in 0.07, 0.07 we already get. Okay. After going for the calculation, the value will be 10 to the power negative 15 by 11.2. If you calculate this, you can write this in the form of 100 by 11.2, because if you are taking 2 zeros over here, and that exactly cancelled with the 2 zeros with the negative sign also. That's why 10 to the power negative 17 we wrote. So here we have 10 to the power negative 15 actually, but it can be written, this is exactly is equal to 100 into 10 to the power negative 17, because 2 zeros from this, 2 zeros from this cancelled, no? So that in this way also we can write. Okay, so when you're writing like this, 100 by 11.2, so 100 by 11.2, if you are going to calculate, 8.928 will be the value. So whatever this 10 power is there, that remains the same. Okay, so here 10 to the power negative 17, which is already given in this problem, 10 to the power negative 7 part, which is known to you. Only the thing to be calculated is unknown y. Y value is 8.928. That value is taken. 8.928. So you can round it as 8.93, right? So this is the way the 8.92 or 8.93 you can put over here. Question number 3 can be answered as 8.92. So this is the kind of question coming from the chemical equilibrium, and analytical part it will be. So it is the problematic session. So move on to question number 4. Question number 4 is collected from JEE Advanced 2019 paper 1 question paper. At 143 Kelvin, the reaction of xenon tetrafluoride with O2F2 produces a xenon compound Y. The total number of lone pair of electrons present on the whole molecule of Y to be identified. After getting Y, so total number of lone pair of electrons present on the whole molecule of Y to be identified. So how many lone pair of electrons are to be depicted? In order to get the lone pair of electrons, first of all, we have to know about what is Y. In order to know about Y, what will be the reaction carried over there? Xenon tetrafluoride upon treating with O2F2, what product we will get? Xenon is the noble gas. Exceptionally, only the noble gas which will show the reactivity only towards the two elements. One is with the fluorine, second is with the oxygen, because these two only the more electronegative elements, right? That's why they only polarize this xenon noble gas, so that only reactivity is possible with the two elements only, and we will get halides and oxides for xenon, not else compounds. No other compound is identified for the xenon. You can notice xenon halides, xenon oxides only, right? So that extent reactivity exceptionally shown by the noble gases. Noble gases are highly inert in general, but this is the exceptional condition, we can say, towards only two elements, right? So what is Y and how many lone pairs are there on that? In order to get that one, so the expected answer is 19. So we have to get this 19. How can we get this 19? So let's see. Xenon tetrafluoride was given. Xenon tetrafluoride upon treating with O2F2. O2F2 when treated, it will be fluorinated, because oxygen, fluorine, both are competing with each other. But fluorine is more electronegative, right? So that it will be reacted over oxygen. So xenon hexafluoride is formed, oxygen will be generated. Xenon tetrafluoride now converted into xenon hexafluoride. Okay, xenon hexafluoride is geometry shown over there. Whenever xenon hexafluoride geometry is shown, you can see the octahedral geometry like this. Octahedral means what? So 4 fluorines are laying on the plane, 2 fluorines are laying on the axial position, and remaining 4 are called equatorial position, and still xenon is exhibiting one of the lone pair of electron, right? So one of the lone pair of electron is existing on xenon. Okay. So if you observe the entire one, in order to get this geometry, this xenon will participate in a hybridization. What hybridization? One s orbital, 3 p orbitals, 3 d orbitals got mixed up. We have to mix up s, p and d orbitals in this proportion, so that sp3d3 hybridization will be generated. sp3d3 hybridization, if present, so one more bond is required, but in sp3d3 hybridization, one of the xenon is showing lone pair of electron only, that is not participating in the bonding, because we have only 6 fluorines, right? 6 bonds only required. One of the lobe is occupied by the lone pair only, so that it is not exactly perfect octahedral, rather it will be the distorted octahedral. Xenon hexafluoride is exhibiting distorted octahedral. Distorted means somewhat deformed. Okay, so actual question is how many lone pairs are there? In order to count lone pairs, each fluorine is accompanied by, if you see any halide, here 2 electrons, here 2 electrons, here 2 electrons will be there. That means what? 3 lone pair of electrons are there. 3 lone pair of electrons on each fluorine, right? 2 plus 2, 4, 4 plus 2, 6. 6 plus 6. Here also 6 will be there, because this is also fluorine, no? So 6 plus 6, 12. 12 plus 6, 18. 18 plus 6, 34. 34 plus 6, 40. 40 plus 6, 46. 46 plus 2. 46 to 48 will be there. Okay, so this is the way number of electrons we are counting. So just what we have to do, lone pair of electrons to be identified. 3, 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 9 plus 3, 12. 12 plus 3, 15. 15 plus 3, 18. 18, 1 is there on the xenon. So that 19 totally. 19 total lone pair of electrons are present. So lone pairs are 19. Individual electrons we counted also. So whatever they are asking, that only we have to answer. Total number of lone pairs. How many are there? 6 fluorines are there. 6 fluorines are accompanied with each accompanied with 3 lone pairs. 3 multiplied with 6 fluorine atoms. So 6 3s are plus 1. Total 19 it will be, right? This is the way you can answer the question. For question number 4, 19 will be the correct answer. Move on to question number 5. Question number 5 is collected from Telangana Gurukulam Degree College Lecturer Entrance Examination. This is the compound called terpenoid. The product formed in the following reaction is. So alkaloids and terpenoids is the content which is related with biomolecules, which is called a natural product. So this is the terpenoid molecule, and we can say bicyclic terpenoid compound it will be. It is treated with CH2I2. CH2I2 is called diiodomethane. CH2I2 is the reagent. Zinc is the catalyst. GLYME, glyme is another what we can say, that is the co-catalyst we are adding. RT denotes room temperature conditions we are applying, and this reaction is carried for the period of 4 hours. 4 hours of time duration you are doing, and these curved lines indicates what? The entire reaction is performed under microwave irradiation condition. We are applying microwave light. So under these conditions, how the reactant is converted into product? They are saying about another cyclic product will be generated, or else two iodo functional groups are generated, or else this cyclization may be carried among these two double bonds, these two carbon atoms, sorry, or else one of the iodo only substituted. Among these many options, the correct expected answer is option number 1. Okay, and moreover, the starting material what we are taking is called alpha pinene. This is the compound called alpha pinene. Alpha pinene is reacted with CH2I2 by cycloaddition under microwave irradiation. So let me show the detailed reaction for this. This is called alpha pinene. Its IUPAC nomenclature is provided 2,6,6 trimethyl bicyclo 3,1,1 heptatoene. This is the IUPAC name of the compound. Okay, so whenever it is treated with CH2I2, CH2I2 is a compound where 2 iodo if removed, you can get a CH2. CH2 is called what? Carbene. This is called a carbene. Carbene is having a peculiar nature. Peculiar nature means one of the lone pair is there, one of the vacant orbital will be there. Lone pair will increase the electron density, vacant orbital will decrease the electron density, so that lone pair is ready for the donation, vacant orbital is ready for the acceptance. At the same time, it is having electron releasing nature, electron accepting nature. That's the reason why carbene is denoted as a amphipyle. Amphipyle denotes what? The same intermediate which used to give the electron pair, at the same time which used to accept the electron pair, that is called amphipyle. Carbene is the amphipyle. Lone pair is released to one of the double bonded carbon, and this pi bonded electrons will be accepted by vacant orbital, so that this CH2 will be bounded to carbon-carbon double bond like this. This is the way you can go for the simultaneous cyclization over there, three-membered ring will be originated. So the expected answer will be option number 1. In order to achieve this option 1, the mechanism proceeded with carbene intermediate. Carbenes, nitrines, benzene, all these are said to be intermediate. Based on the type of intermediate formed, what product we will get will be decided, right? So for question number 5, option number 1 will be correct answer. Move on to question number 6. This is the last question of the session. Again, it is collected from the organic session. Moreover, photochemistry part it will be, right? So in this photochemistry question, the product formed in the following reaction. This is the symmetrical alkene. We can say symmetrical alkene means where this side how many atoms are there, this side also same number of atoms, this side also same number of atoms, and moreover here one double bond, here one double bond, here one double bond. It is the kind of system you can notice 1 2 3 4 5 6 7 8. 8 atoms are present and 3 double bonds are present, so that we can simply say, and you can clearly notice that it is the kind of bridgehead carbon atoms containing species, and octatriene species it will be, right? So actually this is the parent chain, we can say hexadiene, and one more diene is also there in another chain. Okay, applying the photolytic condition, H nu for what? Photoliter. Okay, and sensitizer. The role of sensitizer is, we have to know a new term over here. Sensitizer is nothing but any compound. This is the compound we are taking, no, where we are having double bond, double bond, double bond like this. This is the starting material we are taking, but itself will not be reacted. Itself will not be reacted with H nu conditions. Okay, this is a light inactive molecule. That's why there is a kind of material we required which used to accept the light, which used to facilitate the reaction, which is called a sensitizer. Okay, this is the way this triene can be treated with H nu under photosensitizer conditions. We will get a new compound, being it is a kind of rearrangement. A new compound will be generated, that is given in the option number 2. So this will be this is the kind of used molecule you can see. This is a cyclopentene. This is another cyclopentene. Both are connected with another three-membered ring as well. How many cyclic rings you can notice? 1, 2, and 3 ring systems are there, right? So at that condition, in order to achieve that one, there is a mechanism for this reaction which is collected from Liber text. Okay, here is the tricyclic system. Under photolytic conditions, it will be rearranging within the molecule like this. Whenever it is rearranging like this, it can be simply represented by one of the 5-membered ring system, in either 5-membered ring system, and another 3-membered ring system is there, and further transformation, another kind of rearrangement gives rise to octatetraene also. This is also another possibility, but one of the expected product is a tricyclic ring with 5-membered, and 3-membered. That only given in this option. That 8-membered ring is not mentioned, so that we can clearly go with the option number 2 only. Right? For question number 6, option number 2 will be the correct answer. By this, we entirely completed the session where different dimensions of chemistry covered over there. Definitely, if you're observing this session, you can improve your thirst towards the chemistry, and we will get more into the chemistry, right? And I will assure for definite cracking of your examination, you're seriously aspiring about, either it might be entrance examination or competitive examination. This will be very much informative session. Hence, I'm sincerely requesting you to like the channel, comment over there, share with the aspirants who are serious about the examination, subscribe the channel to achieve more such updates in the near future. Thank you one and all for your patient listening.